This is AB Calculus, section 6.1, page 5. We are going to start off playing a guessing game here. I want you to look at a slope field, and then I want you to see if you can figure out what I typed into the slope field program, and then I want you to find the solution to that slope field. And here's the first one. So I'm running this slope field program. And there's the slope field being generated. So I want you to look at this and see the general trend here. Decreasing slopes, flattening out, increasing slopes. And this looks like what shape? That looks parabolic. So the solution to this slope field, what do we see? We see a parabola or a quadratic, y equals x squared, and then all these different parabolas varying by some constant c, raising up that vertical shift, which means what did I type into the program? I typed in dy dx equals 2x. That's the derivative of x squared. Let's see, 2x. Yes, that is what I typed in. All right, let's look at another one. And let me see if I can turn this up. There we go. You should be able to see that. Let me run this slope field program. And again, you're looking for general trends, general shape of the curve. What do you see? The curve that we see, well, clearly it's a sine or a cosine. Which one is it? It's a cosine curve because cosine starts at its maximum on the y-axis and then drops down and goes back up. So the answer here, or the solution to this differential equation is y equals cosine x plus some c, some vertical shift, plus c, which means then that I must have typed in dy dx. So what's the derivative of this? The derivative of cosine x is negative sine x. And when we check to see what I've typed in under y equals, yes, y equals negative sine x. Okay, now we have a little bit of experience with slope fields now. We're going to take a look at each differential equation that we have here and think about what characteristics that slope field would have. And when I want you to look at these two derivatives, this one over here, dy dx, is not dependent on y. It only depends on x. And this one over here, dy dx is y plus 2, that one is dependent only on y, not dependent on x. So it only depends on what the y does. Okay, so with that, then let's just go ahead and investigate these just a little bit further. What does this mean when a derivative is not dependent on y, it's only dependent on x? That means that as x stays constant, and y changes, the slope dy dx also remains constant because that's not dependent on what y is doing. Let's make a quick sketch of a slope field here for this problem just so we can see what's going on. Quick sketch. We'll just do a few points. We won't do many. All right, let's look at what happens at x is 0. If x is 0, then the slope is 2. I'm going to have to kind of estimate here. Slope is 2. Doesn't matter what y is. Slope is always 2. So right in here, this entire vertical stretch, right in here, the slope is 2. What about when x is 3? So at the point 3, 0, at 3, 1, at 3, negative 1, at 3, 2. Any of those, the slope dy dx for this particular problem is the x value plus 2, so that's 5. Oh my, that's very steep. A slope of 5. Nearly vertical here. So all in this vertical stretch right here, the slope is 5. And to further describe that, the same slopes going up and down the slope stays the same vertically when dy dx has only x's. Slope stays the same vertically when dy dx has only x values. All right, let's take a look at this one over here where dy dx is dependent only on y. That means that as y remains constant, and x changes, the slope, oops, didn't mean to do dots there. The slope, dy dx, does not change. And if we sketch a graph here, again, doesn't have to be perfect. Quick sketch. Just generating some slopes. When, let's see, let's just do this one, because if y is equal to negative 2, if y is negative 2, then those slopes will all be 0. So at y is negative 2, we have a bunch of horizontal tangents here. So all these guys right here are occurring when y is equal to negative 2. Let's see, what about if y is equal to 2? If y is equal to 2, regardless of what x is, the slope will always be 4. These guys are all slopes equal 4. Regardless what x is doing, as long as y is remaining constant, then that slope is remaining at 4. So, same slopes horizontally. Happens when dy dx has only y values. Oops, my page got turned crooked. I'm so sorry. I hope you can see that okay. This is the last page of notes for this section. I will post a video for homework help for, I don't know what page it is actually in your worksheet, but you'll recognize the picture when you see it. It looks like this. I will post a video for homework help on that page. Thank you.